All right, starting up the streams for day 7. Let me see if I got good AV Sync test 1, 2, 3, 4, 5. Looks good. Looks good. I even have quality options today. Nice. I don't know if I had quality options on the first stream. So let me just get a few things squared away before people start coming in. I'm doing Advent of Code. If you're seeing this in the VOD, I am going to be doing day 7. And I just did day 6 like half an hour ago. So I actually haven't checked this in. So let me do that so I can keep these separate. So just, go back a directory. Just commit this. So this is add 2021 day 6. Just so I can keep the commits separate between days. All right. So let's make a day 7. It's already day 7, man. All right, and then we'll make placeholder for running day 7. Like that. We'll make day 7.text. We'll copy some day 6 to day 7. Oh, I didn't need to do that. Aha! 7 and 7. Okay, in our day 7, let's clear out everything. Let's fix that. I always make that mistake, so now we're not going to make that again. We don't know if part 1 and part 2 will be the same, so let's go back to like a day 5 structure. Like this. Okay, and then just remove the code. And then like when I'll set up, I'll give a little intro for people that have arrived to let them know what we're doing, and then we'll start doing the puzzle. So I need to also list a module for day 7 here. Whoops. And do another import. Day 6 is a little complicated because we wanted to compare with someone else who doesn't actually profile the parsing code, and so that's why that looked a little bit different. All right, so we'll make sure that this runs. And this, 2021 cargo run 7.1. It did not run because because it's not yet implemented. That's what I wanted to see. Okay, cool. So what are we doing? We are doing Advent of Code, AOC. So I've been doing Advent of Code this year. You get to do 2 programming puzzles per day from December 1st to 25th. They're all Christmas themed. They're kind of wacky, corny, but really what you get out of the puzzle challenges are little challenges to write programs to either implement some kind of weird algorithm or just try to interpret the rules and get an answer. And there's 2 ways we can play this. It can go speed run it, which I can't do. But for example, yesterday's that I did earlier, someone solved this in 2 minutes and 9 seconds. It took me, what did I write down? It took me 12 and a half minutes to solve it. Now, a lot of that is me reading through the problem. The speed coders don't do that. They jump straight to the answer. I don't know how they do it. They're pretty cool, but I'm not going to be doing that. I'm going to be doing a more laid-back approach. I'm doing all of these solutions this year in Rust because I'm really into that language. Some people will challenge themselves to pick a language they're new to or want to learn. In general, the puzzles get more and more challenging as you get into the month, although last year and so far this year, it's not been wrapping up so high. A few of the days were a little bit more challenging, but you know, it's not like we're taking hours to figure out an answer. So we'll see how it goes. So all right, ready to start. And it unlocks midnight Eastern time. So this one unlocked 24 minutes ago. So I'm actually going to wait until it says 24. So we're 24 minutes behind, no big deal. Day 7, the treachery of whales. A giant whale has decided your submarine is its next meal, and it's faster than you are. There's nowhere to run. So the premise, if you missed days 1 through 6, are we had the keys to Santa's sleigh, and we accidentally dropped them in the water, and now we have to go fetch them out. And it turned into this whole undersea adventure. So now we're in a submarine. We're being chased by a giant whale. You got to read through days 1 to 6 if you want to see the whole story. Anyway, suddenly a swarm of crabs, each in its own tiny submarine, it's too deep for them otherwise, zooms in to rescue you. They seem to be prepared to blast a hole in the ocean floor. Or preparing to. Sensors indicate a massive underground cave system just beyond where they're aiming. The crab submarines all need... See, that's kind of ironic. Crabs, rust, and all that. They all need to be aligned before they'll have enough power to blast a large enough hole for your submarine to get through. However, it doesn't look like they'll be aligned before the whale catches you. Maybe you can help? There's one major catch. Crab submarines can only move horizontally. You quickly make a list of the horizontal positions of each crab, your puzzle input. The crab submarines have limited fuel, so you need to find a way to make all of their horizontal positions match while requiring them to spend as little fuel as possible. For example, consider the following horizontal positions. So the examples have been fitting pretty neatly into the form of something that we can set up as a unit test. So that's what I'm going to do. I'm going to paste that text directly in as the example, and then when they say what the answer is, we'll fill that in. This means there's a crab with horizontal position 16, a crab with 1, and so on. Each change of 1 step in the horizontal position of a crab costs 1 fuel. You could choose any horizontal position to align them all on, but the one that costs the least fuel is horizontal position 2. So 16 moves to 2, the most fuel. Everyone else uses a little bit of fuel, except for 7, takes 5 fuel. Oh, I guess in the last one too. This costs a total of 37 fuel. So that's the answer to our unit test. This is the cheapest possible outcome. More expensive outcomes include position 1, 3, so on. Determine the horizontal position the crabs can align to using the least fuel possible. So right away, something that springs out to me is that probably the least fuel will be the average, right? Or near the average, if they're distributed evenly, but I don't know if they are. So another thing that comes to mind is if these are all positive numbers, then the least likely to be the right answer is something on the extreme ends. So it's more likely to be in the middle. So I wonder if we should just have it start with a guess. No, maybe we should just do brute force, because I can't think of it. I was just going to think, try to find the guess, but then we still have to somehow eliminate the other possibilities. So, how many positions are there? I guess if we look at our puzzle input, we'll find out. Get our puzzle input. Okay, quite a few. They're in the thousands. Good to know. Let's grab our puzzle input, paste it into 7.txt. So, I'm trying to think if there's a way we can incrementally get there. So if we started at 16, we know that the least fuel is not to move. The most fuel is to go all the way to 0. Right? Or to go in the other direction, 17. We don't yet know what the largest position is, right? Then when we get a 1, don't we immediately know that the cheapest is the middle of the two? Right? That's easy. But what about when we get the third one? How do we know that it's cheapest to go all the way to the left near the 1 and the 2? I guess we would, the middle of these two would be 8. Right? 8 and 7 is we know it has to be the cheapest. Actually, that's not true. Because if we move the target anywhere to the left or the right between them, it's 1 cheaper for one and 1 more expensive for the other. So then, it's not until we get a third one can we say that it's cheaper to go near those 2. Because anything further costs 2 more for them, 1 less for that one. So wouldn't I just keep combining that? So it would be wherever we pick a place in the sand, so to speak. When the next number comes in, we want to move all the way towards that number as close as we can, right? Anyway, I think that's the algorithm that I would pick. So 16, destination is 16. 1, then it doesn't matter. We'd stay at 16. When we get a 2, then we know that every time we move closer to 2, we're gaining 1, right? And we would probably end up at around, well, we would end up on the 2, or we would end up at the 2, right? Yeah, because that's the least amount of fuel. But when we throw in 0, we know we can move 1 to the left because it costs 1 more for the 2, but 1 less for the 1 and the 0. Right. So every time we add a number, we have to consider how many numbers are to the left and to the right of it, and then move that goalpost until it balances again. Right? Let me see if this will work. So we would take the input, we would split on comma, we would map that to numbers where we have to trim them, parse them to, for convenience, let's just do I32, unwrap. Right? Let's just type this so far. I don't know if anyone has actually watched. Oh, there's Egoist. Hey there, Egoist. How are you doing? Yeah, I did something weird today where I streamed solutions to day 6, and then I had to take a 20-minute break to run an errand, and now it's starting again. And I had rated someone, and it's possible everyone who was watching me is now sticking with the person who I rated, because let's face it, they're probably a better streamer than I, more experienced and all that. Anyway, so it's possible I have a lot fewer viewers this time, even though, yeah, because of that, having the second stream start off. Anyway, let me turn back on inlay hints. Hey there, Meme Clear Bams. How are you doing? All right, so given the numbers, I think what we want to do is we're gonna do some algorithm inside of a fold, or should we just do reduce? Because reduce starts with the first element being the initial value of the initializer, right? I haven't used reduce a whole lot, so let me look it up. Reduce, iterator reduce. So we have to give it a function that takes 2 items, and it gives us and returns an item. It's the same as fold with the first element of the iterator as the initial value, folding every subsequent element into it. So it has to be the same type, though, which is fine because we're just going to deal with I32s, right? So we do have an option at the end which will unwrap, and then we will end up converting that to a string to output it, right? And this function then takes 2 things. So it's, I guess, our initial goal, well, not goal, what to call it, like estimate, and then some number. And then we have to figure out, so if we just go with the estimate right now, we'll get the wrong number. Why is this not correct? Why does it want a semicolon? Oh, because of the let x. Get rid of the let x. So this will give me the wrong answer. It'll give me 16, but let me verify. 16, right. So then, instead of just returning the estimate, if we do something in here like, we have to remember how many things are to the left and to the right of every number before it. So I think we need to keep track of, like, keep a sorted list of the numbers, actually. Actually, why not just make a tree that does this? No, actually, you know what I think I'm going to do is just have 2 lists, left and right list. So then instead of doing a reduce, let's do a fold. And let's make, just for convenience, let's make a structure that holds this stuff. What to name it? Like state or something. Lack of a better name. Hope I'm doing well. I'm doing okay. Because of life, you know, can't do everything at the exact time I want to, but that's okay. I can still do this, so I should be really happy. I'm going to want to have vectors and numbers, I think. So left is a vector, and right is a vector. Okay, and then fold will take, well, let's just, for convenience, let's just implement the, can we just say implement the default by derive? I can't remember if I can do this or not. Can we do that? I can. So I can just have the initializer for fold be state default. And then this is state, not estimate. And I should have an estimate in here. Which means I can't have, well, the default can be 0, right? Yeah, that's fine. But when we unwrap, so we don't unwrap the fold, we do a map. So map the state to the state.estimate when we're at the end. Okay, and then in here, we're going to mutate the state because we're going to return it. All right, so given a new number, it's either going to be to the left or to the right of the estimate we're given. Actually, for the very first one, we can make a special case, right? Or do we need a special case? I think we do. Otherwise, it's just going to... Actually, it doesn't matter. So I can ignore the special case of left and right both being empty. We want to add it to whichever side of the estimate it's on, basically. So if n is less than the estimate, what if it's equal to? If it's equal, we know we don't need to move at all. So that could be a special case, right? Yeah, so we can just say estimate.compare n. And I think with compare we do a borrow, right? And then match in front. And then say fill match arms. So if it's equal, we don't need to do anything. For, let's think about for each of these less, if the estimate is less, this would make more sense if I swap them. And it's the state.estimate. So if n is less than the estimate, then we want to put it on into the left list. And problem is, we're going to want to sort it. I can just say left.push. Can I say insert sorted? We'll just push it. And then left.unstable sort. Sort unstable. Sort. I know why, because I need to put state dot in front. Sort unstable. Right. And then we know that the estimate probably needs to move left, right? So then, right, we're going to move the estimate until we can't move it anymore. We can't move it anymore if it throws off the balance into the other direction too far, right? So we can move it left until it hits Yeah, until it hits the last one in the left list. So let's just put a loop in there at the beginning. And then if state.estimate is greater than state.left.last.unwrap. Actually, if the left, what happens if the state left is empty? Let me think about that. Then we don't want it to move. So I can just say if state.left. If it isn't empty. And then loop for now. I'll probably change this. What? Oh, dereference. So that's that. All right, so then I can close this so everyone can see with the extreme indentation we're about to perform. Yeah, if it's greater than, we can definitely move it to the left. Actually, that's not true. We only want to move it left if... Oh no, we know it's out of balance because we push a new one into the left. So we want to keep going until it... yeah, so this would be continue. Actually, it doesn't really matter because it's else. What if it's equal? If the estimate is the last one on in the left list, then don't we want to stop? No, if it's equal, we want to... If it's equal, then, and we move left, we'll end up putting one or more things onto the right list, and that could throw us out of balance. Oh, well, we can just put one over there. Hold on. No, we can't, because you can have more than one number, one of the same number, right? I wonder if I should change this, these lists to be, instead of vector of numbers, a vector of number, and count, like a count of how many of those number. I think I got this right. If it's equal, we want to stop. Actually, then I don't want to just track, in my mind, I don't want to track just how many are on the left and how many are on the right. We want the sum of all, we want the number of numbers. Yeah, okay, I'm going to change this. So let's make another struct position. And that is, there's the, when it's not just a position. Crabs. Position, I32, count, view size. There we go. And then left and right are vectors of crabs. Yeah, okay. So then we don't just push n, actually. We have to find n, we have to see if the position already is in there, and if so, we just increment the count. Otherwise, we do add it to the end, and the way we sort it is based off of his position, so I need to implement partial ORed for crabs. Partial comparison. Why did it fill it in like that? Really, it's just self.position.compare other.position. And it's some... Oh, I need partial equal. Okay. They're never equal. Why do I need to implement partial equal? I don't need... I can just derive that. Yeah. So... Oh, I need a dereference. Anchorini... Okay, I don't know how to say your name. Anchorini? Hello? How are you doing? Doing Advent Code Day 7. I started about, what, 15 minutes late? It's been 26 minutes. We're 45 minutes into it. I should have written... Oh, I should have written this down. I think I started 20 minutes late. Anyway, this is taking me longer than probably the speed coders did it in, but that's okay. So yeah, I have to first see if it's in the list, don't I? Can I forget, can I implement something for that? I cannot. Nope, because vector's out defined outside. Okay, so then I'll just make a function, I guess. So function add crab. Crabs, borrow mutably some crabs, a vector of crab. In fact, I should probably, what, make a type for that? Type crabs equal, well, crab lanes. Crab groups. It's a vector of crabs. I meant to do that. And then crab would just have a position. And then, so it would be if... It would be for crab in... Well, crabs. This is crab groups. For crabs in crab groups... If crabs dot position equals position, then crabs dot count plus equal 1 return. Otherwise, do I need to? I don't need to sort after. Yeah, okay. I just need to add one at the end. Crab groups dot push crabs and fill in fields. The position and the count is 1. And then crab groups dot sort unstable. There we go. So then this just says add crab state dot mutably borrow state dot left and put in the n for the position. And we don't need to sort. Okay. Group of crabs is called a consortium. It's groups of groups, though. That's where I'm getting kind of stuck on it. Or was it a cast? This logic I'm not too sure about. So, this is just because to avoid the unwrap, right? Why is my dog scratching the carpet? I've never seen her do that before. Why is she scratching the carpet? Hey, why are you doing that? You find gold? She find gold, chat? She scratched like digging on the carpet. What'd you find? I think she's just bored. Anyway, okay. So, this is always going to be false, so why am I even doing that? We know it's to the left. We're adding one in there. I don't need to do this. Okay, that's why I wasn't sure about it, because it was wrong. So if the estimate is... This is not always true. It'll be true the first time through. Saw the whale coming and knows the cave is under there. I see. She's trying to find that cavern. She's trying to help the crabs. Okay, I'm getting hung up on this. Oh no, I'm being raided back from Anthony Wright's code. How are you doing? I'm a little bit stuck on figuring out day 7. So I guess you must have solved it, like faster than I'm gonna do. I'm gonna be struggling with this all night probably. Thank you for the return raid. Welcome back, some people, and welcome a lot of other people. Yeah, I'm trying to figure out the core of the algorithm of, I think, you probably can chuckle when I tell you that I have this completely wrong, but I think the algorithm I'm going to follow while parsing the input is I'm going to form groups to the left and to the right of the current estimate, which will start at some arbitrary position, and we'll put the crab on whichever side it should go on, and then we adjust our estimates so that if there's more to our left, we move the estimate to the left until we start to move amongst the group on the left, and as we do that, we move stuff from the left to the right, and we try to keep it balanced. I'm on part 1. Yeah. You got an SQLite solution? Wow. See, the first part of solving part 1 is figuring out the algorithm, and I'm still trying to figure that out. The second part would be to actually implement it in a programming language. And then part 97 is to implement an SQLite because it's so hard. I think my algorithm is sound, but we'll see. So like, in other words, like if our arbitrary position was 0, you say, okay, add crab 16 on your right, and then move to the right all the way until you're on top of 16. And now you're balanced because there's nothing on the left or the right, right? And then you add 1, so then you don't need to move because it doesn't matter. In fact, if you move towards the 1, you're just making more fuel for 16, but less fuel for the 1, so you just don't move. But when you get the 2, now it's unbalanced, and you have to move all the way to the left until you get it on top of the 2, and then you have 1 on your left and 1 on your right. So you'd stop at the 2. Then you get the 0, and it's like, okay, now you're unbalanced again because you have 2 on your left, 1 on your right, and so you move 1 left to the 1, and okay, now you have 1 on your left and 2 on your right. I guess it doesn't matter, so then you would stop, right? So you'd stop on either 1 or 2 because it's the same. Then when it's 4, then you'd move back to on top of the 2, I guess, because then you have 0 and 1 on your left and 4 and 16 on the right, and you just keep going until you just do that in a loop. That's my algorithm so far. It'd be interesting to graph the fuel cost as you move the line. I think that's the algorithm. The tricky parts are going to be like how we handle the left and the right, because sometimes you can, like when you have a second 2, now I have to remember that there are 2 2s and all that. So I'm trying to model this by having crab groups, and crab groups are vectors of crabs, and a crab is a position and a number of crabs. And when we add a crab, we first see, is there already a group at that position? If so, we add another one. Hey, new friend. Otherwise, we have a whole new group of crabs. And what's wrong with my sort here? ORD is not satisfied. Really? I have to implement ORD? Okay, fine. Implement ORD. But that was the idea. And the sorting is important because when we are moving our estimate and we hit the edge of a group, we need to know which group that is quickly. So I figure I'll want to keep my groups sorted. Ord requires equal. Does it? I forget, what's the difference? Like a total order. Now why does it require equal? Okay, well, we want to toss out count. It doesn't matter. We just want it to be on position. So really, I think I want to derive all of these. Partial equal for crabs and equal for crabs. Oh, wasn't there like a placeholder, like you just say that they're equal if you implement partial equal? So you can say derive equal and ord. If I remember right, you can just say that. And then, yeah, we just want to say sum. No, it's a Boolean. There's no sum. Self.position dot equal other position. We only want the position to be taken into account for sorting, not the count. The count is like auxiliary data. Okay, so now that works. So yeah, so the core of the algorithm is we take our input, split it along the commas, then this map does all the parsing for us, so we get an iterator of numbers, and then this fold is starting with our default state, which is empty crab groups and an estimate of 0, doesn't matter, and then looping through all of the input, right? One number at a time. We compare that number to our current estimate, and if it's less, that means we're going to put the crab on the left, and we're going to start moving the estimate to the left, and this is where I was, right? We want to move the estimate to the left until we hit a group, and then we need to decide, do we stop? I guess we would stop. We would always stop, and then we decide, do we move that group to the right, or actually, no, we need to have another group called the group that's on the estimate, don't we? I think we do. Yeah. Yeah, I think I convinced myself that this is a crabs. And the default for crabs should be, there shouldn't be a well, I guess it's 0, 0. To implement default, I guess I have to derive default for that. That's fine. We can do that. Implement default, please. Thank you, Rust. That one was irritatingly hard. Oh, today's, you mean? Thought it was the easiest day after day 1? Really? I guess if you had seen this algorithm before, you'd be like, oh, I totally know how to do that. It turned out not to be that bad. Oh, it's easier than I think? Yeah, don't give me any hints yet. Day 6 set us up for failure. Day 6 was actually pretty easy, right? I did it in like 12 minutes, and that includes all the reading and stuff. I need to compare it with the estimates position. And actually, if it's equal, don't we just add it to the group? Yeah. So then state.estimate.count plus equal 1. Okay. Actually, then, isn't it just that... Actually, I want something back from this. I want to know how many crabs are in... Actually, no, I don't. I don't need that. Never mind. I want to do... Yeah, I want to say while it's unbalanced, right? So while it means I kind of want a complete sum. So something like left sum and right sum, which means that when I add it, then I need to add to the left. So state.left sum plus equal 1. So then it's while it's unbalanced, right? State.left sum is greater than state.writeSum. And we move it by, well, we might move it if the number of crabs on our estimate is doesn't throw it too far out of balance, because we could be unbalanced. So I guess we could say if state.estimate.count is less than state.writeSum minus state.left, it's left minus right. So this is probably a horribly overcomplicated answer, right? Then we put, no, it's not this actually. It's this, the one on the left. Yeah. No. What am I thinking? Why didn't it like this, by the way? Whoops. What's my cursor doing? Weird things. A U size? Oh. Yeah, make them all I32 so I don't have to worry about typing and stuff. If we put the crab to the left and now the left sum is too large, that means we got to move the one in the estimate to the right, but only if it doesn't throw it out of balance too much in the other direction. So what is that number? So that's if this number is greater than what it would be if we move the estimate to the right. So that would be left sum. It's got to be an easier way to do this. Isn't it just that it's greater than the estimate count? Times 2, right? This is the current balance. Actually, I don't even need two numbers here, right? I can just say balance. And then I kind of want to do that. So it would be balance minus equal 1. While state.balance is less than 0, then, so let's say it's -1, and the estimate count, we need a special case actually if it's the first one, because the estimate has to actually have a crab in it. What if I make that special case here? If state.left is empty and state.right is empty, then something otherwise. This and this something will be that state.estimate.count equals 1, state.estimate.position equal n. Right. This should be position. What's wrong with this map here? Probably because this is wrong. Anyway, You graph the fuel cost over 10,000 range, and there's the only one minima. Day 6 is not like day 7. Once you see it, oh, it's a lot like day 7. Is that a hint? You got a 1.5 millisecond runtime. Yeah, I had a feeling this would be a little bit more complex. A lot of over-optimizing. In day 6, yeah, we did a lot of over-optimizing, right? I did way too much optimizing for day 6. Gotta focus. So this would be balance, state dot balance, negative state dot balance. So if we have one crab and there's one too many on the left, then it doesn't matter, right? But if there's two on the left and there's only one on our current estimate, we should throw it over to the right. So that would mean that if the absolute value of this balance is greater than the number of crabs that we have on our estimate, right? Then move it to the right. So the estimate's always going to be on one of the two ends, I think, to keep it balanced, right? I hope. So then two operations, right? No, I just need to add, if I make this add crab take a crabs, then I can just say add crab mute state right state dot estimate, and state dot estimate is take crabs state left. Right. This one right here. I'm having trouble with this one, obviously. Crab's position is N and count as 1. Add crab takes crabs. This should just be crabs. If new crabs dot position crabs count plus equals new crabs count. Otherwise, push new crabs and then sort. Right? Okay, so now I need to take crabs. Take crabs from crab groups. And it's always like, oh, I need to say whether it's left or right, right? How about we'll just take crabs left and take crabs right. Crabs. So how to take the one on the end? It's let crabs equal crab groups dot left or dot last dot unwrap. Actually, it just, can we do pop last? Pop removes the last. That's exactly what we want. So I don't even need to do that. I just do assign. I just do that. Is there a pop front? We're gonna need take crabs right. I don't know if there's a pop front. Can I remove the first one? Remove returns the element at a position index shifting to the left. That's what I want, actually. Remove 0. What does remove do? Does it just panic if, yeah, it just panics if it's out of bounds. Okay, so we just do that. All right. I guess I could have used remove with the length -1 for that instead. Doesn't matter. Okay. So I don't need to take the negative of that, do I? Yeah, so if there are more, if the balance is shifted too far to the left, then we take the current estimate and put it onto the right, and then the estimate has to become the one we took off the left. And then I need to adjust the balance here, right? So I guess I can do it in 2 steps. State.balance plus equal the double the number that we moved, right? Actually, that means I need to have it be this times 2. And this is the amount, right? So we need to get that first. Let shift equal that amount. And we shift the balance that far. Actually, then I can do that at the end. No, it's not just that. No, I did this wrong. I need to know how many are in this group that I take off the left, because that gets taken off the balance. We're going to move this count onto the right. We're going to add it to the balance, and then we're going to take off. Yeah, okay, so I did this wrong. I need to calculate the new balance here, really. So it would be state.balance, and no absolute value here either, right? Actually, yeah, they both have to be absolute value. The balance, but then add state est count and subtract state left last unwrap count. That looks so ugly. Yeah, and so I need to actually state dot balance plus equals state estimate count and subtract, no, add again. Yeah, we're adding both cases, right? We moved stuff to the right and we also took off from the left, so that's actually that's this again. And that has to be filled in here. Okay. Wait, did this not return? Oh, it's just state estimate. All right. If I get the good thing is if I get this right, then the greater is just we flip it around. I hope this is right. I'll be really sad if I didn't get it right. So if it's greater, then it's the other side. We add the crab to the right. And we add to the balance instead of subtracting. And if it's, while it's greater than 0, oh, another thing I should have checked is this is else break. This means the balance is to the left, but it would put it too far off balance to put it onto the right. So if the balance is the other way. No, it's the same thing. It's if it puts it too far. If it doesn't put it too far off balance, then but I need to minus that and plus right first. Then we subtract in both cases, and we add the estimate crabs to the left, and we take the crab from the right. Right. Okay, now what does it not like about my map? It says it's a state. Oh, right, it's not, I just do dot estimate position. There we go. All right, are we ready for me to fail? No, we're not ready because there's... Oh, we need to borrow this. Shoot. How does this work? This consumes it, so it's going to complain about it being moved. Iter mute. Or no, I just do mute here, and then, nope. That's not how we do it. It is iter mute. What am I thinking? Okay, there we go. I have one more error. What is it? You're driving OR, but I've implemented OR explicitly, and so I don't need to do that? It's only equal has that weird thing? One other error. Sort unstable doesn't work because OR's not satisfied. So this is saying I have to implement OR explicitly? Is it the other way around, that I can implement partial OR if I implement OR? Is that how it works? I forget how this works. Let's see. So this is just self.position.compare other position. Oh, I have to implement both of them? Okay, fine. Let's implement both of them then. Part 1 is done. Good for you, TS Joss. Did you start on time? Because that means I have 20 minutes to beat you. Self.position.compare other position. I got a warning down here. Oh, that's fine. Okay, let's see. Let's watch it all break and watch me cry. Ready? Let's go. I failed. 37 was the right answer. Oh, wait. The cost is 37. Was 14 the right answer? What's the cheapest? 2. 2 is the cheapest. Okay, so 2 problems. I output the position, but I should have output the fuel cost. The other problem is it stopped at 14 and it didn't go to 2. So we'll just have to take it step by step. Let me fix this obvious problem, though. We need to get the fuel, not the position. So I have to, like, add up the fuel for the left and the right, right? So, I need to do a map here. Map. Well, I could just say compute fuel. Let an implementation on state do that. Function state. Consume self. Why not? Give me the fuel cost. The fuel cost will be self.left.fold 0. Actually, it's just sum, right? Yeah. So map iter into iter map crabs dot position. So it's going to be the distance, right? So state dot estimate dot position minus crab's position. It's not state itself. Times the count. Times crabs dot count. And then sum that, and then we're going to add to that the same for the right. only here it's the crab's position minus their the estimate position. Sum didn't work because of why? Can't satisfy for iteration of sum of I32s. Consider specifying the type argument. Iterator of I32s. I thought sum would... Do I need to actually say I32? That's odd. You would think sum would just know the type. 12 minutes total. Wow. That's awesome, TS Just. I'm just really slow. I'm already an hour into it. Hey there, Red Rampage Crumpet. Crabs and fuel, what could go wrong? I know. Saw an experimental highlighted and knew what was coming. Yeah, anyway, this is wrong, so where to debug? Let's debug on each loop. So where do I put the debug? Can I put it here? I can put it here. There we go. That's where we're gonna put it. I need to mark it as debuggable, so let's do that. So state, where's my state? Down here. Make it debug, which means crab groups and crabs need to be debugged. So do it. And then fuel doesn't work because... Wait. What happened to fuel? Did I accidentally delete it? I probably did. Let me undo until I get it back. Oh, I called it state. Yeah, okay, redo. Fuel. Probably someone in chat told me I didn't even see it. What am I doing? I'm debugging. Crab groups and stuff. I'm trying to I'm coming up with my own like half-hatched algorithm. What do you think I'm doing, TS Just? I'm coming up with like the most insane algorithm you can think of. And then someone in chat's going to say, you didn't need to do that insanity. You could have done it much more easily. Oh, did I undo too much? Apparently I did. Okay, what's wrong with this? Okay, state got moved where? Oh, here. Yes, so how do I do that? Well, one way would be to make it copy. I think I will do that, because I'm lazy. Make it copy and clone and copy. Because I'm lazy. Why? Okay, clone then? I mean, I'm trying to tell you to just... Why is state moved? Where line is it moved on? 298? What? Well, hold on. I'm not reading that right. It's moved in some kind of macro. Part 3 is going to be playing bingo with the crabs? I know. Okay. And I know, I just realized half of this error message you guys can't see. I'm sorry. Alright. I can't read that, so... Clippy, tell me what I did wrong. Move a Corsica state has... Oh, it's mutable. Yes. Oh, the move happened there. It's my debugging caused it to move. Alright, I didn't mean to do that. So, I can remove all this stuff. It's the debugging that did it. I still need it to be debug, but I can't debug like that, so I need to debug a different way. Let's just do it the easy way. So print line state. There we go. Good old-fashioned print line. Let's run it. All right, let's go through. So we start off with nothing. Then we estimate position 16. Then, I see the problem. Yeah, we lost the crab at position 16. How'd that happen? Let me think about this. So there's an estimate. Oh, it's this. Shoot. I know an easier way. Yeah, I know what this should be. This should be if state.estimate.count is 0. Then we place it in there. Otherwise, yeah, we find where to put the crab, right? We either add it to the left or to the right, or we put it on the estimate. Yeah, okay. So to see if that fixes it. Wouldn't that be cool if that just fixed it? Wouldn't that be cool? No, it didn't fix it. Dang it. Okay, anyway, here's our debugging. So we have no crabs, then we have one crab at 16. Then we have a crab over at 1, and we have a balance of -1, which is fine. Then we have 2 to the left. Okay, that's a problem. It should have moved the, with a balance of -2, and then a count of 1 there, it should have known that it could balance it out. So I must have done my math wrong. Let me think about this. It would be less. The balance would be -2. So if 2 is greater than -2 plus 1 minus 1, which is definitely true, right? Actually, I think this is wrong. I think this should be a plus. But anyway, 2 is greater than -2, right? So it should have gone into here and moved it. So what if I print out moving crabs to the right and then moving crabs to the left? Run. We never moved them, so why not? I mean, it's nice to see that the sorting is correct, at least. Right? They're all being sorted correctly. 0, 1, 2, 4, 7. Yeah, okay, so what did I do wrong? Oh, do I have it backwards? Should this be estimate compared with n? I think I have this backwards. I think I have it backwards. Let's run again. It's still not moving it. It's just putting the balance on the wrong side. So then, do I have it backwards in more than one place then? Let me think about this. The n would be like 0 compared to 16. So yeah, it should go on the left. So this is correct. But then what did I get wrong down here? It will be less than 0. This should be, yeah, greater than 0. Let's debug this. One. Wait. Hold on, I need to print more. Let's not debug that. Let's print them all out. So print line. State. Balance. Let's just do this instead of this, and I'll considering, well, let's just print that. Actually, I know the balance is there. What am I doing? What am I doing? I don't know what I'm doing. I think I need to print it there because I need to print it after the balance is changed. So I think that has to do with my bug, as I was looking at that wrong. Right, this makes more sense. There's 1 to the left of the estimate. Then there's 2 to the left. Why did we not shift it then? I really want to... can I debug this entire expression? Yeah, I can. So let's do it. False. So negative, well, okay, this one, let's consider this one. It says it's false. -2, so absolute value of -2 is 2. If 2 is greater than -2 plus 1, which is -1, minus the last count, which is 1. -2, oh. I think that should be a plus, not a minus. Or -2, -1, zero. Yeah, it should have been a plus. And probably this should be a minus. This should say left, not right. And let's debug both sides, because it's probably not right. And should I just let's say considering left, and considering right. Oh, it actually passed that time. Well, there we go. Let's verify I did the right thing. So put it on the left, put it on the right, move the craps to the left. Oh, it should say right, not left. Dang it. To the right. This is left. Okay, so put it on the left. Right, so it's balanced. Well, this is where we know we can't rebalance it. Then we put it on the left again, and then we might be able to balance, move it to the right, and now the balance is -1, where our estimate is now position 2. There's 1 to the left, which is a 0, 1 to the right, which is a 16. Then it doesn't say what the next one is. Well, we can see it here. Actually, I didn't print that. What was the next number? I should put the next number in here, or just remove all the debugging since it's probably right. This should say something like added blank to the left. So that's N. This should say added to the right, and then we can just remove this. And then this should just say added to the middle. Run. I just want to be able to read this. Added 1 to the left. Added 2 to the left. Moved crabs to the right. Added 0 to the left. Added 4 to the right. Added 2 to the middle. Added 7 to the right. Added 1 to the left. Added 2 to the middle. Added 14 to the right. Yeah, because once we arrive on 2, it just stays balanced, right? Okay, so then dare I try it with the real input? Can someone who's worked with Rust tell you what the big draw to Rust is? Haven't I told you my reasons, Crumpet? It was that I was able to write a lot of my code without having to worry about race conditions and like buffer overflows and numerical overflows, because rather than it being undefined behavior, Rust actually catches it. A lot of it's actually caught at compile time, but even the runtime stuff it'll catch and give me an immediate feedback that I did something wrong. Syntax is horrible? I don't agree with that. It was difficult to learn, but I think a lot of it was because I was used to C++. I think if I had approached this as a new programmer or with some knowledge of programming languages it's inspired from, like OCaml, for example, that it would have been a lot easier. Yeah, those are the big things about it. That despite the difficulty for me learning it, it's the fact that it's that there's a lot less undefined behavior in a normal program. The compiler or the runtime will catch a lot of my mistakes a lot earlier than I ever had with C and C++. Syntax is a learning curve? Yeah. The fact that it's got different string types is actually, I think of it as a good thing, because there are differences between those types. So there's the owned string type, capital S. The names could have been chosen better. I think there's a bias in Rust to abbreviate. FN instead of function. But like the str here, the full name would be string slice, right? And a string is not a slice, it's the whole deal. It's a capital string, right? And then you have like the path and the path buff. Those are because the character sets are different. So again, the names might not be the best, but capital string and string slice are UTF-8 strings. Path and path buff are strings in the operating system's native character set, which may not be Unicode. So like there are reasons behind it. The names, I guess I would say one of the weaknesses of Rust is the names are too abbreviated for newcomers. But then again, you might call it a plus because there's less typing. I don't know. There's like trade-offs, right? Definitely there's abbreviation. CMP is compare or comparison. So maybe if you had like something that unabbreviated Rust, it would read better, and you could actually make the names mean like carry more of the meaning, and maybe it would make sense. Anyway, let me run the real solution and see if I got it. Cargo run 7.1. The debugging is going to kill me, isn't it? Should I just turn off the debugging for now? Yeah. Oh, anyway, it got an answer. Should I try and see if I got it? Nope, I messed up. Is too high. Well, fortunately, we have debugging. Unfortunately, it rolled off the top of the page. Well, let's log it to a file. And to one it. That. So I can get error and output at the same time. And let's look at the output. Okay. So we have 1101. And then added 29 to the left. Then, oh, we forgot to show that we added 29 to the left. Decimate's 1101. We have 1 to the left. Why does it say 1 instead of 29? That's the bug, isn't it? That should be 29, not 1. Why does it say 1? 29, and yet it says 1. That is incorrect. All right, well, that's one problem. Added 29. Okay. So where does n go? I don't get it. We put it into the position. Where did it go? Oh, we didn't print it after the add. So I should like do that there. And do that there. And run this again. All right. Look at it again. Added 1 to the left. Sure. Added 29 to the left. There it is. Balance is -1. Moved crabs to the right so that we have move crabs to the right and add 67 to the right. So we have 20. That's not even correct. It should have moved. Oh, is it not sorting correctly? Oh no, that's right. The 29 moved to the right because our estimate. Sorry. Our estimate's 1101. We have 1 and 29. Yeah, it moved the wrong thing. It moved the wrong thing to the right. See that? Oh no, sorry. When it moved the crabs to the right, it should have said it moved 1101 to the right. Then it added 67 to the right. Oh no, that's still correct, right? So then, because the estimate's 29, so we have 29 is the estimate. We have 1 on the left, 67 and 1101 on the right. The balance is 0. Balance should not be 0, actually. Balance should be 1. What? The balance is off. That's the problem. How did I screw up that balance number? This balance isn't right either. Okay, the balance is not did I not print out the balance? Ah, shoot. I did it again. Print it after the balance is updated. And really I should say moving some number. State.est.position. State.est.position. Can I safely say that I've lost day 7? Add 1 to the left. Add 27 to the left. Balance is -2. Moving 1101 to the right and added 67 to the right. Is that balance correct? 1 to the left, 2 to the right. Yeah, that's correct. Add 1102 to the right. Balance is, yeah, added moving 29 to the left. And then added 0 to the left. But I'm not ending up with the right answer, right? 336122. That's not the right answer. It's too high. Maybe start over? Gonna be here a while? Don't care for abbreviations. White screen monitor is pretty common. It makes sense to use them. Yeah. Well, it could be just that my wow, there's a lot of crabs at the end. End up with a balance. Is that the last line? It ends up with a balance of 4. No, it ends up with something to the right. I think actually I should print at the very end. That should go there. Let's just print again down here. Lots of prints. Okay, so what do we have final? Balance of 3. I mean, I guess I could double check that the balance really is positive 3. What's the estimate at? 308? Count of, with the count of 1, it shouldn't, the balance of 3 shouldn't matter. What's on the end then? Where does it say right? Oh yeah, there's immediately to the right of the estimate there's 6, so it can't move those to the left. 308 was the estimate? No, 308, yeah. Yeah, then there would be too much. Well, hold on. Balance of 3. And then there's 6 to the right, and we're on 1, so we would actually, wouldn't we want to take that? We would want to take 6 off to the right at the cost of adding 1 to the left. Yeah, am I just off by 1 then? I think I might just be off by 1. Yeah, I think I might just be off by 1. It's this condition, right? So what was the final one for that? It would help if it didn't wrap it. Balance, which is -4. Oh, but it stopped. Wait a minute. That wouldn't work. -4 plus 1 is -3 plus 6 is 3. Oh, that is true. So yeah, I think the decision, this decision is wrong. But how to fix that? So the middle is there's one crab. To the left there are 4 more to the left than there are to the right. So it seems like we want to move something to the right. But when we do, we're moving a large group of 6, which is wrong, right? I don't even think my balance calculation's right. Hold on, let me check. Let's count. So we're moving to the right. Okay, so balance is left versus right? So when we move something to the right, we're adding it to the right. And we take off the left, we're taking off the left. Oh, wait. No, that's right. So how did that add up then? So if it's at -3, then we push it to +3. Oh, but we added 250, so it's really -4, right? -4, it's +6 is 2, and then +1 is 3. I don't know, then it seems the right decision, doesn't it? I'm having trouble thinking. No, this can't be right. What's the extreme end of the left? Is just 1 at 307. So there's 1 to the left, 1 on the position we have, and 6 to the right. It seems like we should shift it to the right. But why is that? Because because I don't think my balance is computed correctly. I think I need to be counting it as, yeah, I don't think this balance isn't computed correctly. Yeah, it's not correct, right? It should be the number of crabs times the distance from the center. So yeah, when I shift it, I'm not. Yeah, so this is incorrect. I can't just do that. Oh, shoot. So left, it doesn't matter left or right. These are both wrong. The balance isn't right. I bet if I calculated the actual balance, it won't be right. why don't I just do that for to confirm? So like we'll print down here actual balance is some number, right? Where it's going to be what fuel calculates, right? These ones. Actually, it is the difference between those. State. Right minus left. Yeah, okay, so I bet you this is going to be completely wrong at the end. It didn't compile. Why not? I moved it out right, so it should not be into iter, just be iter. Okay. So I can do Rust, I just can't do algorithms. Hey, but what's new? You guys knew I couldn't do algorithms, right? This is why I'm failing miserably. How come I can't just go to the end of the file, like everyone else? Yeah, see, my balance is way off. Look at that, it's way to the left. So yeah, of course my answer is wrong. So I'm not accounting the balance correctly, obviously. How to do the balance correctly? I need to account for how far we moved the estimate. Don't I? Hey there, Indians. How are you doing? You take like 4/5 small numbers and work out your algorithm by hand? That's what I did when I started. So return to day 7. I did it with this one, and it worked. That's what led me to a false sense of security, because my part 1 actually works. Although yeah, the balance is wrong, but because the example was so extreme, right? The next one to the right of 2 is 14. So even though it was heavily weighted to the left, you couldn't move it to the right without throwing it way out of balance. I think, right? Something about that. Like, it had to be 2. If you went to 1, it was way too extreme. If you moved to 14, it was also off. Yeah, if you move to 1, it's 41. So even though my balance estimate was 1, it was off by a lot. The 31, it wasn't off by enough to make a difference. But in the real thing, it was. So I just need to think of what these lines here are wrong, is what it is. The balance is not right. What does moving to 2 or 1 mean? You mean, what do you mean? Oh, you're supposed to line up all the crabs, right? So if the crabs are all in these positions and they can move left and right, but it costs fuel, then where do you line them up for the minimal fuel? They say line them all up at position 2. So it costs the one at 16 and 14 a lot of fuel to get there. The ones already at 2 don't need any fuel. And the ones to the left and the right of 2 need some fuel to move there, right? And so the number where they don't need any fuel is what I'm calling the estimate, and it's moving as we build from left to right. So you start with 16, you say, I estimate 16 because there's no fuel. Then you add 1 and you're like, okay, well, I can't move to 1 or I can move to 1, but there's no improvement, right? Either the one at 16 has to move to 1, the one at 1 has to move to 16, or they have to split the difference somehow, right? It doesn't matter, so you just pick any position. But when you add 2, now you're like, okay, now it's heavily balanced to the left. So then you pick some position. Actually, you know what one of my problems is? No, it doesn't matter. So you'd pick anything between 2 and to the right of 2. Is a wash, right? Because But it costs more for 1 and 2 to move farther to the right than it does for the one at 16 to move to the left. It costs twice as much fuel, in fact. Actually, that might be the solution about how I'm calculating this balance. It should be the number of things on your left multiplied by the distance, right? Is that it? Is it just counting the number of things on the left and the things on the right? Not their positions? Is it as easy as that? For more than 10 seconds down to 1.4 milliseconds. Nice. All the crabs have to move to the same location. Yes. Yeah, I mean, it makes more sense if you read, but I read this over an hour ago, so I understand that you missed it. I think then I don't add the count. I just add, no, I do have to add the count because it's that many crabs. So how am I off in this balance then? Should I just look at the top of this out file? Which is now such a massive file, it takes a long time to load. And it's really lagging when I scroll. I really should print the balances as we go, and I should do the small example. That's how I should that's how I should fix this. So let's do that. Oh, being rated by Grim. Hey there, Grim. I'm horribly failing at day 7 of admin of code, but even in failure, we have fun. So it's taken me like an hour and 40 minutes to make a way overcomplicated solution to admin of code day 7. But I will learn from this experience. I swear I will learn. Okay, I really want to calculate this at every stage. Oh, then I'm putting this in the wrong spot, aren't I? I want to put it actually outside of this. Down. Oh, actually, move all this. This is my debugging print statements, right? Move it to there, and then delete this redundant one here. And we'll just run this with the built-in unit test. Were you doing advent to code, Grim, or are you doing something else? If you weren't doing advent to code, I should give your viewers an introduction. So advent to code, different programming puzzles, 2 a day from December 1st through December 25th. And we did 1 through 6 without any problem. On 7, I'm just totally like falling over flat. But they're Christmas themed, so they're pretty cheesy. The whole theme is that you dropped right around here. You dropped the keys to Santa's sleigh in the water, and they're tumbling down into the ocean now. And now you're in a submarine, and you're chasing whales, and I don't know where we're going to end up. But on day 7, it's that we're being chased by a giant whale, but the swarm of friendly crabs are going to help us beat the whale into an underwater cavern by blowing a hole in the ground to where the cavern is underneath. But in order for that to happen, you have to have the crabs concentrate their fire, and so you have to line them up. It's all contrived. So these are the positions horizontally of the crabs, since crabs can only move horizontally, apparently. It's like, what's the minimal fuel to get them all lined up to shoot at one spot? And that's what we're trying to calculate. You're doing pigeon stuff? Okay. Yeah, we played bingo with a giant squid at one point. Now we're lining up crabs to shoot holes in the ocean floor. Of course, because it makes total sense. But it's I think I'm falling flat because I'm not an algorithm designer. I'm an implementer. That's okay. We'll figure it out. The big part of today's puzzle is figure out an algorithm to find the optimal position. So in this case, it's 2 because the total amount of fuel, for each crab will consume fuel by moving, right? So the one that's at position 16 to move to 2 costs 14 fuel. The ones that are already at 2 don't need to move. Then you sum up the fuel, it's 37. If you were to try to move them all to position 1, it would cost a little bit more fuel. 3 would have cost a little bit more fuel, so that's why 2 is the right answer. So I just noticed something. There's even more fuel to move to positions 10, and 3 and 10 and nothing in oh no, there's a 4. Never mind. One thing I realized right away is that if like there's no difference between the fuel from 5 to 6 really, because if they're balanced, because you're having one side use more fuel, the other side use less fuel, if they're balanced. And that's probably the reason why my algorithm is broken, because right now I'm calculating balance as I move things around, and I don't think I'm taking that into account correctly. So I'm trying to figuring out by looking at what the unit test produces. So we start off with it perfectly balanced with one crab at 16, and the actual balance matches my estimate, which is good. Then we add a crab at position 1, which is to the left. So our balance is -1, and our actual balance is 15. Okay, that's the problem. That's the problem. These are wrong. It's actually 15. Why is it 15? Because, oh, I see. Because we're picking position 16, but we put the crab on the left all the way at 1, so it's going to cost it 15 fuel to move over to where we are. Oh. I see. Okay. So when I update the balance, what did I do wrong? How did I end up at -1? When it's really 15. We placed it to the left. So that happens up here. So we only added... Wait, why is there a 1 there? Oh, that's the problem. That's one problem. It shouldn't be 1. It should be the difference between n and the estimate, not 1. Yeah, okay, so then this is n minus state estimate position. And then this one should be state estimate position minus n. Actually, it doesn't really matter. I can just have the same thing on both sides. It affects the balance the same. Okay, now how does that affect my output? You want to solve it myself? Yep, no tips. You're going to watch me struggle. That's the price. Usually I do this in 10, 20 minutes. And it's no big deal, but now it's going to be one of those nights where you have to, oh, I got a unwrap failure. You're going to have to watch me suffer for a bit. I'm sorry. Why did I get an unwrap failure and a panic on line 108? What did I do wrong? Shouldn't it have added it to the left? Oh, probably because of this while, right? It moved it, and then it... Yeah. Wait. Why is it while less than? Oh, probably because this is not correct now. So it added to the left, it moved it to the right, and then panicked because the balance was still wrong. Sure. Okay, so I need... So when we move 16 to the right, what does that mean? That the new estimate became whatever was on the left, which was 1. So we actually shifted 15. We added 15 to the balance, not 1. Okay, that's the problem then. When we move the crabs in the middle to the right, well, actually, that shouldn't affect the balance at all at first. Yes, it should. Never mind. It's when we move this estimate here that we need to recalculate the balance. But what is the equation? Crap. So if it was at 16 and it moved to 1, that's a shift of 15. Thank you, Red Rampage Crumpet. Thank you for your confidence, but I that's okay. I know I'm doing. I've already fallen fallen face down, flat on the floor, and I'll probably continue to do that for a little bit. But then I'll have the eureka moment, and then I'll be like, I can reduce this problem a lot. I just need to get to crack that. So, This is not even right. Wait a minute. I just thought of something. What if we just line all the crabs up and then just find the balance point by walking left to right until we get a balance of 0? Wouldn't that make more sense here? I'm trying to keep it balanced as we're adding crabs, but that's totally the wrong way to do it. It'll have like a really high fuel cost, which will be the sum of all the multiples, and then we'll just reduce it as we shift things over, right? And we just keep doing it until it goes the other way, and then we stop and we take the lower of the two numbers. Yeah, well, I'm gonna just do that. Okay, new algorithm. So that means I'm going to do what? I need to collect. I still need the position in the count. I still need to sort. I still have my crab groups, but I don't need a left-right anymore. Where was that? The state. I don't need this left-right stuff. I can just have... I don't need an estimate either. So I just have the crabs and the balance. I don't need the state anymore, do I? Well, the state is convenient for debugging, so let's keep it. Let's just have crabs. Crab groups. And then fuel is something that will collect as we go, so we don't need that. Okay. So in the initial fold, it's just to add it in. So it would be add crabs. Add crabs does what I want, right? It finds if there's already a group of crabs at that position and adds one to it. Otherwise, it adds a new group of crabs and sorts it. Because ultimately we want to sort it from, we want to sort them all. And then we'll just go from left to right, I guess. So, end that fold. What type do we get? We get a state, exactly. Okay, and then with that state, so let's just say state, mutable state? State? Sure. Do I even need a state then? I don't even need a state. What am I doing? Let's get rid of state. So then, where was state again? Right here. I'm looking at it. Crab groups. And this is a crab groups default. And then remove that. What's it telling me? Unmatched, unmatched, unmatched. Oh, not remove that, but add that. Okay, so we have a vector of crabs. In other words, a crab group. Crab groups. And then, yeah, let's just get rid of all this. It's all junk. Yep, all junk. So it's all nice and sorted. In fact, I can do the sorting last. I don't need to do it in line here. Let's do that there. Make this mutable. And make that to do. Expected unit type. What? Wait, what? What's it telling me? Oh, to fold I gotta do, it's not state. Crabs. Or crab groups, really. I need to put that there for fold to work. And then, there's no left. It's just add it to the groups. Okay. Then sort them. Then we're going to, I guess I could have accumulated the cost as we go. Well, hold on. Just brute force it. Just have it recalculate the fuel, like, every time and just walk through it. I guess we'll start with that. So then I'll want a method on this, or just a function, I guess. Fuel, given a crab groups and a position. I-32, right? Returning an I-32. All right, so then if we want to calculate the fuel, we're just going to iterate. So crab groups, iter map crabs. It will be the absolute value of the position minus the crab's position times the number of crabs. And then sum that. Right? What's wrong here? Oh, that's okay. That's just because I'm using a type alias. So yeah, I'll fix that. Just say that. All right. Okay. So then, we have to start with one number at least. So let mutable fuel equal, well, crab groups 0. Well, we can take the position of the first group. Position to start with, right? And then we can say loop let mute, actually let's get that position first. Let mute position equal this one. Position, and then let mute next position equal I feel like I should be iterating through this and taking windows of 2. Well, but then that would be really redundant. No, hold on. I can, you know what I can do is I can consume the position. No, I can iterate the positions. No, I'll figure this out. Dirty. We'll do this a dirty way. That means I don't want an I don't want a position there. I want this to be an index 0 and make that an I. And then I'll make this a while. We shouldn't hit the end though, right? While I plus 1 is less than crab groups dot length. This is horrible. Hey there, Adam. I'm being rated by Adam C. Eunice. This is a totally different stream than Adam's stream, but I hope you enjoy me struggle with basic algorithms. I'm falling flat on my face with Advent of Code. Day 1 through 6 went smoothly. Day 7, not so well. Yeah, I'm only live because this is taking me so dang long. Like 2 hours. We're 2 hours into something that should take like 10 minutes. Because I'm really bad with algorithms. So Advent of Code is every December since 2015. You get 2 programming puzzles that are pretty closely related. Each day from December 1st to the 25th. We're on day 7. And they're Christmas themed. They're pretty corny. So the theme this year is that you, dropped the keys to Santa's sleigh in the water, in the ocean. Now you got to go find them. And, they've already sunk to the bottom of the ocean. So get in your submarine and go after them. And we're doing really crazy things like playing bingo with a giant squid. And day 7 is about a giant whale is chasing us. But not to fear, a swarm of crabs who are on our side, each in their own tiny submarine, can help us by focusing their what is it? It doesn't say what they're using, but they can blast a hole if they're all lined up. They can blast a hole in the ground in front of them and open up a hole so that we can escape. But they all have to be lined up, and we're given their positions along an axis. They can only move horizontally along that axis, so left and right, just like a crab. And the problem is, where do you line them up to consume the least amount of fuel? Because of course, when you move a crab, it consumes fuel. So if you move the crab that starts at position 16 over to the position 2, it costs 14 fuel, etc., etc. You add it up. The optimal position is 2 because it's 37 fuel. If you moved them to the right, one to the left, it would cost a little bit more. Move to the right, it would also cost a little bit more. So it's this algorithm of given a list of numbers, what's the number that when you add up the costs to get there for all the other numbers to be moved, what's the minimum? And I suck at algorithms, so I walked through what I thought was a good algorithmic solution to this. It was totally wrong. I abandoned most of it, and now 2 hours later, I'm starting with like something that I think will work, where we just basically sort them and then calculate the fuel given 0 and then 1 and then 2 and then 4 and then say, we found the right position, it's 2, and just stop. So we'll go down, we'll go across, and the fuel will go down until we get to the sweet spot, and then when it starts to go up, we stop and we say we found it. And I think this algorithm will work. It's a very brute force. It's horrible, but it's going to get me the answer, and I'm going to move on because I've already spent 2 hours on this problem. So this is all in Rust because it's my new favorite programming language. Sorry, it's not C# or C++, but maybe with inlay hints, which are the gray characters, maybe it might make a little sense. So the input is given as a borrowed string. We're going to output an owned string. There's a subtle difference there I won't get into, but our input looks like this string, right? And we expect this string on the output. That was given to us from this example, right? So I'm using their example. We should get this answer given this input, and then the real input is so large as to make it impossible to calculate by hand. It goes for, I don't know, let's turn on word wrapping here. For pages and pages, right? Lots and lots of numbers. So prohibitively expensive to do by hand. That's why we're writing a computer program to do it. So the idea is we take that input string and we split it on the commas, and then we map each thing that we split out, trimming the white space off, then parsing it as an integer, 32 bits, and then crashing if it's not a number. And then fold is basically taking that list of numbers and then folding them together into something, and that something is my list of crabs. So I have the default group is empty. For every crab, we call this add crabs, which is going to walk through that list and find if there already is a crab at a certain position, we just stack them. So we have a counter for each position. And if we can't find any position where of a crab already that we've already placed, we just add a new group. So each of these groups is just a position and a count, right? And we have a vector of those. So in the end, we get a vector of positions and counts, and then we sort them. I wrote the code here to sort by their position, and actually this is the sorting. The partial ORed is how you define how you compare, less than or greater than, and then this is for equality. I don't know if I still need that one, but basically ignore the counter and just look at the position. So we're sorting them by position left to right. And now here we're going to calculate the amount of fuel it takes all those crabs to get to that first position. And then we're just going to walk to the right along each group of crabs and see if the fuel goes down. And if it goes down, we keep going. But if it goes back up, we stop. We say that, well, that last one, that was the optimal position. And then we're going to return that number. So I should actually write that part. It would be fuel dot toString, and we're done. So brute force solution, right? Because I'm kind of tired. So if we start at position 0, or the group, the first group basically, and calculate its fuel, then while we're not going to run off the end of the crabs list, the next position would be, well, we don't need this to be mutable. It's let j equals I plus 1. Let next fuel equal the fuel of the same group of crabs, but position j instead of I. And then we'll say if fuel is less than next fuel, break. Otherwise, fuel equals next fuel. And continue. Because we expect the fuel to go down every step, right? So if the fuel we already were going to consume is less than what we're going to consume, then we need to stop at that last step, right? If we get to the end, then it'll be that very last group. So I hope this gives me the same answer, but maybe actually works better. Let's see. Oh, I have a bug. Well, if it's a position a crab was not previously at, I don't think that that's possible. Were we regressing all right? I don't know. Familiar with regression towards the mean? No. That's why I haven't been able to find this answer in 10 minutes. I don't know anything about math anymore because programmers don't need to know math. Come on. You know, if I've learned anything about being a programmer for a long time, it's that everything I learned about math in high school and college went out the window unless it was actually part of a job. And so I know a little bit of geometry and trigonometry because I do graphic stuff, but I can't remember anything about median and average and all that stuff. I can only remember really basic stuff that I've had to help my kids with in their math classes. They probably know more math than I do. What's wrong with my fuel function? Oh, because I can't call it fuel. How about we call this one calculate fuel? It feels like we're actually accomplishing something if I call it calculate fuel, doesn't it? Now it will compile, and now I can maybe run my test. Yeah, and it's taking a long time to run because I probably broke it because I didn't increment, right? Yeah. But it did a newbie mistake. Let's just kill that. You have to actually increment I. Or I can just say I equals j. There we go. And it actually gave me a warning there, and I didn't listen. I should listen to my warnings. Okay, so we got the right answer. So dare I try to run the real thing? Let's do it. Isn't that the answer that I got before? 336120? I thought that's the answer I got before and it was wrong. I don't trust it. Anybody remember what answer I picked before that was wrong? I suppose we can just have it print and then give us some more confidence. So let's say print line. Just popping in, what is this code for? This is for Advent to Code. It's a programming puzzle. We're on day 7 of 2017. So, and you can play too. These puzzles all unlock every midnight Eastern time. So fuel 0, we're just printing out the initial one, right? Equals something, fuel. And then we'll print it out here. And that is J next fuel. I want to see this number. What number did I say? I meant to say 2021. Okay, we see the fuel going down, and then, yeah, we did see it reach. What if I just have it keep going and we can have it print all of the numbers? So that would be basically commenting that block out. I just want to see if I'm right in my assumption. Yeah, see, it rockets back up. So maybe that is the right answer. I guess that is the right answer. Just doubting myself. Yeah, we got it. Brute force for the win. Should have done that an hour and 50 minutes ago. All right, so we can undo that, and we can remove the prints. Yeah, okay. It's probably really horribly slow, but at this point I don't care. Let's move on to part 2. Here we go. The crabs don't seem interested in your proposed solution. Perhaps you misunderstand crab engineering. As it turns out, crab submarine engines don't burn fuel at a constant rate. Instead, each change of one step in a horizontal position costs 1 more unit of fuel than the last. Well, this is easy. We're just going to change our cost function, right? Now that I have a brute force solution, second step costs 2, 3, etc., and so on. So each crab moves. Moving further, it becomes more expensive. This changes the best horizontal position to align them all on. And the example above, this becomes 5. So it's a position between crabs. So yeah, so now we can't, it's not going to be a position where there is necessarily a crab. It could be one between crabs, right? This costs a total of 168 fuel. This is the new cheapest possible outcome. The old alignment now costs 206. Okay, so then let's make that into our unit test with the same crabs. All right, close that. All right. So we just want a different cost function, and we want to, when we get to that dip between crabs, then we want to actually go between crabs and calculate the fuel between them, right? So I'm going to say this is calculate fuel estimate 1, and we're going to have estimate 2 in a second, but right now we'll have it copied from 1, right? And then, so part 2 is like starts out like part 1. Only it has the estimate 2 function. And then when we find this dip, we can't just break, right? We need to find the line between those two. So we'll have another level here. And we can start at I again. No, let's start at actual position, which is crab groups I position. And then we'll say while position plus 1 is less than crab groups J position. And then we'll say basically the same thing in here as this. Let next fuel equal... Actually, I need to reuse fuel, don't I? Actually, we need to go back 1 position too, because we might have already gone back up. So I need to have it back up 1, right? So yeah, let's back up 1. So if I is greater than 0, I minus equal, so back up 1, and then we'll recalculate the fuel at that position. Just fuel equals, so we can reuse the variable. And then we'll go to plus 2, no, plus 1 is less than J, yes. So we'll leave J where it was. Okay, and then we'll just look for the dip again. So next fuel is calculate. So instead of it crab's position, it's just position. And actually, we're just going to add 1 right away. And then we're going to say, again, if fuel is less than next fuel, then we found the dip. Brake. All the way out, I think. Actually, the combination of this brake and this brake will do it for me anyway. So does this look good? You have some fuel 1 in there? Do I? I probably already fixed it. So let's see. If we found the place to narrow in on, we're going to step back 1 position because we might have already passed the optimal point. Calculate the fuel. Oh, that's where it is. I see. 2 and 2, right? Thank you. Also stop thinking. Yeah, I'm thinking too much. Exactly. I just need to do it. This is so that this could be equal. Might be the extreme, right? Unnecessary? Oh, yeah. Rust is helping. So we can go all the way up to that position. Calculate, so the starting position. So I can swap these and just put position here. And then this is the next, 1 unit over, calculate the next fuel. And then if it's starting to go back up, we found the optimal spot. And if we fall all the way out, oh, I forgot the fuel equals next fuel. If we fall all the way out, then that means that the last position was optimal. Okay, so I think this will work. Let's try it. No, it's wrong. Did I call the wrong thing? Hold on. It's giving me the exact same answer, so I feel like I did something wrong. Oh, because the estimate's not updated. Yeah. Okay, let's fix the estimate. I don't need this one anymore. Okay, the new one is, or is it? It's like 1 plus 2 plus 3 and so on. So what's a convenient way of calculating that? I guess I can just, there must be an easy way to calculate for n what is 1 plus 2 plus 3 ... to n. I can't think of it, so I'm just going to cheat and make a function to do it. So fuel for distance, estimate 2. Distance I32, give me some fuel. So really it's if distance is 1, then it's 1. Else it's actually you can just do it this way. Let mut fuel equal distance. While let's make this mutable. There's got to be a mathematical way to do this, but I'm too tired. While distance is greater than 0, fuel plus equal distance minus equal 1, fuel plus distance. Return fuel. Is that correct? Yeah, see, I'm not a mathematician. I suck at this stuff. So is this right? So for 0, it would be 0, right? For 1, it would be 1. For 2, or this can actually be a 1, right? For 2, it would be start out at 2 and then add 1, so that's 3. Two steps, right? It's 2 away, so 1 plus 2. Yeah, okay, I think I got it right. I could write a test for this, but nah, that's okay. We'll go for it. So then I'll use that here. This is not correct anymore. It's fuel for cost of this absolute value. Fuel for distance estimate. And take the absolute value of position minus Crab's position. Like that. Not enough parentheses. Add more parentheses until it works. Test part 2. I failed. Off by a little bit. 141. Okay. So let's have it printed. Print this out. Print line fuel at is this. So because I'm just tired, I'm going to print everything. J is next fuel. And then this one's just position and fuel. And then this is, again, position, but next fuel. All right. What did I do wrong? Tell me, computer. So there's where it said, oh, something between 7 and 14. Is that correct? Wait a minute. Yeah, it's, well, no, it's 5. So it's, yeah, so there we go. Wait a minute. These are wrong. These are wrong. 5 should have been 168, not 146. Oh, did I multiply by the count? I might have forgotten to do that. Yeah, I totally did forget to multiply by the count. It's fuel times crabs count. All right. Try again. Yay. So you see, it's like, oh, we went back up from 4 to 7, so let's walk back 2, and then 2, 3, 4, 5, 6. Oh, 5's the best. So let's do this with the real part 2 then. There we go. There's our answer. First time? Yeah. Of course the first time. All right. That only took me 2 hours and 23 minutes. Thank you, TS Just. So, now you guys are all free to tell me what dumb assumptions I made, and you can pile the math on me. And then I can focus. I'm actually mostly interested in optimizing the solution from an implementation point of view. So if I can get the algorithm out of the way, we can optimize the code. Or if you don't give me the answer, I can just optimize what I have. I kind of don't want to look at someone else's solution, though. I just want to know what's the algorithm of the math thing that I missed. To get the sum of numbers 1 to n, use n times n plus 1 over 2. Okay, so there we go. I'll give Blopson a point, because I can just take that equation, because I don't care about coming up with the math, because I'm not a math guy. You give me the math equation, and I will put it in here. So it's this thing, right? So you're just saying I can do distance times distance minus 1 or plus 1, and then divided by 2. Perfect. That's what I'm looking for. I don't need distance to be mutable. We can verify this is still correct by running test 2 again. Perfect. Awesome. Thank you very much. So, any other math insights other than the distance? Because I'm guessing that there's something better than to just walk through the groups and looking for the place where it jumps back up. There's got to be a better way to do it. I'm missing the parentheses? I don't think so. Because you just had Where is it? It's scrolling around too fast. How come I can't see it now? Yeah, n times n plus 1 all over 2, right? N times n plus 1 all over 2. We don't need these parentheses because the order of operations in Rust is right associative, left it's this is done first, and then that is done last. You did the brute force one too? There's no order change with the parentheses. Yeah, that's one thing that I just got in the habit of. I just know that. I mean, I think if we could just add that, and I don't think Rust will tell us that it's unnecessary, so we can keep that. Just the spirit of being more clear to a reader. If you have too many parentheses, Rust will actually tell you, hey, you don't need so many parentheses. Unnecessary parentheses. And if you really like parentheses, you can say to Rust, can it? I'm going to allow if I could spell correctly, allow unused parentheses. Then we can have as many parentheses as we want. Right? Actually, except for Rust Formatter, if I hit save, Rust Formatter deletes all but the last. That's funny. Didn't think the formatter would defeat me. But yeah, okay, so any other insights that I missed? That's the approach you started thinking of, but realized that checking every number wasn't too expensive. That's what I ended up on. Oh, you mean like for part 1? I knew for part 1 we could skip the gaps between, but for part 2 we couldn't because they gave me an example where we couldn't, which made sense. Just skim the mega thread? Yeah, I guess I could do that, yeah. Of course, TSJAS, I overthink things all the time. This is what implementers do. They overthink things. Because they're not... We're us algorithm deficient people. It's all about, like, writing code. So, if you give me the optimal algorithm, I could probably write a better code for this. Where was one thing I wanted to clean up here? Maybe it was on part 1. I think it was that this while loop can go... Oh, no, I guess not, because it could be the extreme end. Yeah, I guess. Unless there's a better algorithm. You brute forced it too? Yeah, but you at least had some insight, TSJAS. I had trouble even figuring out the brute force solution. Or maybe it was that I tried to jump to what I thought was a better solution at first, and it was just my idea of keeping the fuel cost balanced was just completely off. And then it took me a while to realize that. We can remove the print lines, I guess. We don't need that. I can time it. Actually, I should time this. We'll get a baseline from it. Right? And then we can go about finding something faster. So let's bench it. Bench 7-1. Count all the crowds by position, then create a function for each group, and then try to composite the function somehow? I don't know. 211 microseconds. Actually, that's not that bad. What did Sarian say? They got it to like... Sub-millisecond, it's almost like, let's just call it and call it a day, right? I thought it would be much slower. 331 microseconds. Okay, it's not so bad. I honestly thought it would be like 100 milliseconds or something, but it's not even 1 millisecond. 1.4? Okay, so why is mine faster than yours? I brute force. Oh, you fully brute forced it. So now I don't feel so dumb. I thought I was totally dumb by brute forcing it. I thought that there was some elaborate mathematical way to do it that you would obviously find and I wouldn't. Could be Rust versus scripting language? Oh, if yours is slower? No, well, Sarian and I are using Rust. The only difference is Sarian's computer's slightly faster and they don't count parsing, whereas I count the parsing. I don't know, maybe I just call it. It's bedtime for me anyway, right? I just missed out on some gaming that I would have been doing if I had solved this 2 hours ago. Maybe I do just jump and look at someone's solution. So look at Dakra's solution. Triangle number proof. Is that what we ended up doing? Hold on. You have a sparse array, you go over the entire sparse array. Whereas, what did I do? I made an array of counters, really. Array of positioned counters. Is that the same thing? That's sort of a sparse array, right? I don't have any zeros. I just have positions and counts. The expense is that I had to sort them. Where did I sort them? I had to sort them right there. Right after parsing and folding them into that vector, I had to sort them. I guess with the parse array, with a sparse vector, I would use more memory, but I wouldn't need to sort. But it looked like the sort didn't count very much. Yeah, so mine doesn't have empty cells. It just requires sorting. Yeah, with the sparse, yeah. So you actually just put the position as the memory offset, whereas I put it in the cell. 63 milliseconds, but you're using PHP. So is it what, 100 to 1 factor? PHP versus compiled language? Actually, let's see who, a minute and 32 seconds, come on. Hey, but where's our friend, Bataveros? 55 seconds, where's Bataveros? I say friend, I don't know them. They got stumped on part 2. It took them a minute and a half longer, and so they lost 20 positions. But Tavaros is the one that usually like scores in the top 10. And they did pretty well on the first half, but they sunk down to 25 on part 2. How am I doing? Uh-oh. What happened to my self-leaderboard? My personal stats have been disabled? Uh-oh. Why is the page down? Only the personal stats page, though. Okay, well, at least we'll look at the private leaderboard. I rose above Jupit, probably because I didn't... I did Day 6 Part 2 and they didn't. How about the Primogen's new board? I sunk a little bit, quite a bit actually. And this one is for Bash Bunny, I think. Bash Bunny hasn't caught up from day 1. Interesting. I'm still at the top of that, but because it's a very small number of people. Well, I'm sad now. I can't see what my rank is, but it's probably really bad. Having trouble with the boards? Well, that sucks. Well, I guess I can still see my rank later, so maybe tomorrow we'll take a look at that. What was I doing here? Oh, I profiled it, and I think I was just going to call it. Check this in. I'm not happy with, oh, we don't want to check in the out file. That was a huge file. Let's delete that. Goodbye, lost forever. Added that benchmark, added that input, added the whole solution, led day 7, looks good to me. Commit that, add 2021 day 7. Cool. Don't need out.txt. I don't need, I can whittle away at this a little bit, right? I need default though, right? No, I don't need default. Do I need equal at all? I do need equal. What do I need equal for? For ord on crabs. Okay. So we need equal. Did I need partial equal? Need partial equal. All right. There's got to be like a more optimal way of doing this. Like, I just can't think of what it is. The problem is that every time you go one step further, you have to know how many are at each of the previous steps. And then you basically have to, what? You have to incrementally calculate this every step. And that's the thing, right? We're recalculating this every try, whereas I'd like to find a solution where we accumulate to find that. So doing this step by step. And I just can't think of that right now. Hey there, Mr. Balrog, how are you doing? Some kind of binary search to find the minima? Well, I did a search, but I didn't do a binary search. Oh, that's what I was doing. I was looking at the paste bin that was linked earlier. Min fuel is the max for fuel spent is 0. Yeah, so that's the same as what I ended up with. Yeah. Okay, so I don't feel too dumb. Your numbers, though, what type is that? A vector. And do you end up sorting? Oh, you don't need to sort. I didn't think about that. So I can eliminate my sort because technically we don't need it anymore. Right? So this should still work without the sort. Because we walk through the whole list all the time anyway. Yeah, so I don't need to sort. If I don't need to sort, then I could increase the insert time just by using a hash map, right? So we don't need to sort. That means crab groups doesn't need to be mutable. All right. And then they don't need to derive equal, partial equal, and delete all this crap, right? And don't need to sort here. This doesn't need to be mutable. And before I delete too much, see, deleting code always feels good because it's like it didn't need to be there. Uh-oh, I broke something. Part 2 needs to be sorted. Why would part 2 require sorting it? Why would that require sorting? I don't... Oh, because of this? Probably. Wouldn't this have the same problem? Oh, yeah, they do need to be sorted the way I did it. Yeah, it was premature. Then why did part 1 pass? I think it was just passed on coincidence. So it does need to be sorted because I don't actually try all the positions. I assume I can try the first group's position as the first position. So, okay, so I need to put that back in there. Yeah, never mind. We do need to sort it. You can solve the equation, find the point where the derivative is 0. So that would be the calculus level way of doing it that I wouldn't be able to do right now. Did I end up changing something? Okay, yeah, so I don't need that mostly because crabs, I never construct a default crabs group anymore, and debug, we don't do any debug printing. So sure, add that. Drop on 2021 day 7, drop unnecessary derived impulse. All right. 0. Yeah, okay. Well, my friends, the carriage is about to turn back into a pumpkin. I need to go to bed. So I won't be streaming tomorrow, but on Wednesday I'll catch up and do 8 and 9. So who can we raid in the meantime? Anybody still working on this stuff? The people I raided the other day were really fascinating to me because they were solving it in Clojure, and one person was solving it with a spreadsheet. I thought that was really wild. Really ambitious. I could never do that. I don't see anyone I know still doing Abenico, so maybe I'll get to just pass the raid on to one of my friends, Togglebit. I think that's what we're going to do. Hold on. I got to press this button right about... Wait, why did it do that? Did he stop streaming right as I was going to raid him? Or did I just click the wrong button? I just clicked the wrong button. All right. Here we go. Togglebit's a really fun guy. And he's not even a mushroom. He is programming in Rust. He usually programs in Rust. Instead of using Visual Studio Code, he uses Vim. So if you've been hating the fact that I've been using VS Code all the last 2 hours, then I have a treat for you. We're gonna see Togglebit instead. So I'll be back in a couple days. Good night, everybody. Thanks for watching. Sorry that it took me so long to solve that, but we did it. See you next time. Bye.